of your mic?
Oh, no. Someone's thrown off my tape.
Oh, they fixed it.
Oh, that's...
It works now.
Wait, that's what I forgot.
Oh.
I forgot to make sure I don't lose internet. Can you unplug 18?
18.
Yeah, the black cable. And plug one in. Thank you so much. This is not working. Hello?
Well, it's not connected yet.
Is this working? It's not working. This is not working.
Yeah, the mic's not working.
Is the lapel not working? Microphone's not working?
No. Well, we hear you loud in the theater as well. Can't even...
So this is not working.
Well, yeah, no one in the theater could hear you either with it.
No?
Can you... It's definitely... Because it would be loud in the theater, right? No one ever...
Okay.
How are you going to hold a mic and type? Do you want me to just crouch and hold your mic when you're coding?
And like, why is this here?
Could you move your laptop because you're not using this and use this mic?
No. No, I cannot.
Oh, because the HDMI cord.
You have actually got to be
the other
kidding
side
me.
of your
I
computer.
could, but okay.
But now watch the screen not reconnect.
It's better. Come back. Okay. They come back? I'm not kidding you. It's not coming back.
I meant that as a joke, but now it's not coming back.
There we go. We're coming back. Okay. Here we go. There we go. All right. Yeah. Microphone's not working, so I'm like a pop star today with a real microphone. Can't stand it. That one's not working either. I don't know. Can you hear me down the back? Yeah, I can project my voice enough for this theatre, but not for online, I don't think. All right, so we'll start with a little Kahoot. Can you hear me? Okay. Well, the Kahoot, not the Kahoot. Hope everyone's enjoying their Wednesday. People still think I'm going too fast? I'm sorry, I'm going to have to keep going at this pace and then faster next week if you expect to complete this course. Oh,
Thank you.
what a disaster. Why does this always change? How's that? Good? All right, shall we start? Let's start. Let's see what everyone remembers about if statements. A few nice ones to get you started. Oh my goodness. Okay. Okay. So because those who did a hash define, that's defining a constant, whereas we want an integer variable, and then yeah, this one doesn't initialize it. This one declares and initializes, and this one is using the wrong term. Okay, next one. Well, let's see who's... Okay. very good. Oh, that looks like the scanf is just all happening. And the reason it's not the green one is because there's no ampersand in front of the num. And you need to have the ampersand when you're using scanf. All right, Joey's coming back. This one's just to mess with you on a Wednesday afternoon. Yeah, messed with you. Remember what happens when you divide an int by an int? You get an int. You don't get a decimal. All right, let's see what happens next. What happens if you're dividing an int by a double? Very good. All right. Very good. Some people just thought I was just messing with you again. Not that bad. I'm not that bad. That one was an int divided by a double. So, okay. 17 modulus 5. Just testing some basic maths whilst I'm here. What's happened with basic maths? What's happened? Oh my goodness. Hey? What's happened to my basic maths? I'm dividing it. Okay, next one. There we go. My basic maths is going. All right, now I don't know, brackets, multiply, modulus, whatever. Do it all. Show me what you got. More maths. Oh. Quite a few people were one off. All right, so 17 divided by 5, 3. 3 times 5, 15. 17 modulus 5, 2. Okay. Oh, okay. All right. Okay, let's go a little if statement. Only 20 seconds to make your decision. Hello or goodbye? Goodbye, very good. Okay. There was a not, there was an and, there was a bit of everything in that one. And one more if statement. Oh, it's so small, sorry. Okay, people are just kind of choosing whatever now. Okay, one last one. Another if statement to finish off with. I think I did a not in there as well. Yeah. It's a pretty bad condition on line 10. You would never write that condition in real life in code. Oh. All right. That one hurts. Okay, so over here, 5 is greater than 10. No, it's not. Or 10 is less than 5. It's not. Which means that you'll head into the else statement and you'll print goodbye. And then over here, this is a really rubbish line of code here because really they're both saying the same thing. So this one's saying x is equal to y, so 5 is equal to 10. Well, that's not true, but then there's a not outside, which makes it true. And then in here it says x is not equal to y, so really they're saying the same thing, which is how you go into this statement, and that's why it prints world instead of universe. Okay, who's winning this one? Woo! Third place, Sophia! Throw some lollies. Don't know, no one's claiming it. Adam in number 1. They're all online. Oh well, just throw a few out, who cares? Yay! If anyone's traumatized by that, at least you can have a lolly. I'm messing with Sophia because every week I give her different lollies to throw, so she can't get good at one single weight. They're different weights, they're different shapes. Was not prepared, Sophia, you did not give any warning. Wow, Sophia, amazing. All right, good job. Great throwing, Sophia. All right, so the context of today's lecture is going to be a bit weird. For those of you that don't know, Sophia is a Swiftie, and so this lecture is basically an ode to her because she's going to be going to the concert on Friday with about 1 million other people. I didn't really know anything about Taylor Swift until Sophia spammed my inbox with details. Who else is a Swiftie in here? It's not many. I knew it was the wrong audience, but those that are, you'll enjoy today's lecture. I had to print out the details of the albums because I cannot remember them. So this will be fun. All right, so today we're going to be looking at loops and lots of loops. So, I know, exciting. Not just a mixture of Tay-Tay, but also loops. You just can't get any better on a Wednesday afternoon. So, loops. We kind of did an infinite loop to finish on Monday, but it was all a bit wild and fast, and probably everyone didn't really know what was going on and was over the lecture because 2 hours is a really, really long time to be able to concentrate while sitting in one place. And when I was at uni, there were no 2-hour lectures, so I really feel for you. So today we're going to kind of go back and we're going to look at loops all over again to start with. And hopefully we will also get to look at a loop inside a loop, because who doesn't like to loop in a loop? And then I really hope that we have time to look at 2 more data types, and they're custom data types, and they're called structures and Enums as well. And that will be us for this week, and I hope we have time to go through everything. I'll collect feedback at the end if I've gone too fast or too slow. Quite a few of you are saying I'm going too fast. I probably have slowed down as much as I can possibly slow down, but there is stuff that we have to cover, and I may not be able to slow down much more. So do let me know if I'm going too fast. I will try to slow down as much as I can, but keep in mind that I have to bring you up to a certain topic for you to be able to do your first assignment. Otherwise, you're going to be kind of crying in a loop, which is not going to be that nice. The lecture code is in the usual place. There is about 1,000 files. I went to town. Some of them are not schmodded, I think, because I was leaving them as I go, and then I'll do it. Okay, so loops, basically it's a way to repeat code without writing it over and over again. So if I want to do something 5 times, 6 times, or even if I want to do something 3 times, I don't have to write the same code 3 times. And the reason for that is because C executes in order. It goes line by line, it starts in the main function, and then it just kind of keeps going and executes things. We've got if statements. Those allow us to turn on blocks of code, so we can either go into that block of code or we'll skip it, so we can skip some lines of code. But the while loops allow us to repeat our code over and over again until some condition is met where we can break out of the loop. So if we were to do I'll just go to any one in here. Okay, so if I was just to do a while loop, right? And let's say I didn't know what okay, now this is going to get tricky because that doesn't work. This works, but I can't hold it and I don't really know. That's really weird though, you holding a microphone. Okay, I'm going to do this and then type, so this is going to be not that nice either. Great theatre, this theatre. Okay, so let's say I have, I don't know, what should we do? Let's repeat a number. What should we do? How many hours were you online to buy the Taylor Swift tickets?
Probably about
15 hours online, okay. So let's say I'm going to say have a variable that was int hours, and I'm going to declare and initialize it to 0. So what I'm doing here, there is no way I can hold this microphone for a long time like that. Let's try it like this. Oh, look at that. Okay, maybe that will work. Okay, so in here I'm declaring and initializing a variable. And then I'm going to say, let's say every hour I'm going to ask Sophia if she has managed to get a ticket. So I'm going to go, okay, I'm going to print out, did you get a ticket? And then I would probably like to scan something in from that. So I'm going to scan in a character. So to scan in, I'm going to use scanf, and I'm going to %c for scanf. And I'm going to read it into that variable. Oh, I called it answer. So let's do it as an answer. Okay, so now I've got maybe something happening here. This is the first time I've asked her, so I'm going to say that, okay, if this is my first hour, then now that that's happened, I'm going to increase my hours by 1. Okay, so my hours is going to be hours plus 1. So what that will do is it will increase the hours by 1. Amazing. And then 1 hour has passed. She was on there for 15 hours. Every hour she was trying to get a ticket. Well, actually, I did see the setup. You send me a photo. It was wild. There was quite a few computers going. Okay, so then I suppose I'd have to do it all over again. Did you get a ticket to Taylor? And you go again, and the same thing. Pardon? Yeah? Okay. Okay, so then I'll scan in this answer again. And I will place it into the answer, not with that, but with a ampersand. And then I guess this is my second hour, so I'm going to increase the hours by 1 again. So I think you are starting to see that, my goodness, this will get pretty tedious to do, isn't it? If I keep doing that 15 more times, I'm probably going to lose my marbles, and this code, it doesn't feel very flexible, like it can really do much. not very good chunk of code. So this is where the loops come in. And in this case, I'm just going to keep looping until, I don't know, she's gotten a ticket. So who knows how many times that will happen. So when we have a loop, okay, so this is a situation where I want to have a loop. I want to keep repeating something until some condition is met. So when we have a loop, what happens is we will initialize some sort of loop control variable. We'll have a variable that is outside of that while loop, and that's the variable that we use to check whether or not this condition has been met to let us exit the while loop. And then inside the while loop, I'll check in the brackets, I'll check whether I will test that control variable. So has it occurred or has it not occurred? And then before I exit, before the end of the while loop, I'll update it, right? Because something has to be happening. Otherwise, I'm in an infinite loop again if I don't keep updating my hours. So in this case, Sophia went for 15 hours. So I guess that can be our counter. We're going to keep going until 15, and then we're going to stop. So if I were to do it, okay, and I'm pretending like this code now doesn't exist, okay? So this code is now completely, it's gone because it's not efficient. So I'm going to get rid of it because it is just going to be repeating over and over. And I'm going to do it in a loop now. So the first thing I'll do is I'll declare and initialize something to control my loop with. Okay, in my case, Sophia was out there for 15 hours. I'm going to control it with int hours, and I'm going to set it to 0. Okay, and then I want to go into a while loop, and I'm going to test if the hours, so that thing that I'm controlling for is less than 15. So what that will allow me to do is it will just allow me to keep going until 15 has been reached, or 14 in this case, because 15, it will exit out of it. Okay, great. So what I want to do then is I want to print out so if this stands, I'll print out, did you get a ticket? And I'm going to scan in the answer. And then I want to increase my hours. So in this section over here, this is where I've updated the control variable. So this will allow me to keep moving across until I get to 15. Okay, so let's see if that actually does anything. And although 15 is a really, I'm just going to pretend like you did it for 3 hours, if that's all right, because 15, that's a lot of times to enter something in. Let's pretend like that you're almost a normal person who's not going to try for 15 hours to get a ticket to a pop stars concert. So now let's try and run it. Actually, you know, we used to camp out and sleep outside Ticketek on Big Day Out before the day before. I don't even know if Big Day Out still exists. Okay, so let's run it. Now there we go. Perfect, that's because I'm in the wrong directory. Okay, great. So now let's run it. Did you get a ticket to Taylor? No. Did you get a ticket to Taylor? No. Did you get a ticket to Taylor? No. Oh, and it's run 3 times. And since you didn't get a ticket in the first 3 hours, I guess this kind of holds true. So that's a loop where we kind of counted down to something, and our condition was a counter that allowed us to exit out of the loop when the condition is met. If we're to kind of run through this code and we're to do this code, I'll just quickly run through it so that you can see what the loop does. So on line 31, why isn't it working? Come on, today I did it and it was beautiful. Nope, it's not going to work for me today. I'm going to comment through it because my graphics tablet also not working. So everyone's gone on strike on Wednesday afternoon. So over here, I've got a new variable. It's hours, and hours is equal to 0. So that's initialized. Now in here, the first time I go into the while loop, what happens is hours is compared to 3, which means that I'm comparing 0. Is 0 less than 3? This is true, which means that I go into the while loop. So go into the loop, and that means I go in here. I do my printout. Then I create another variable answer in here, and I scan something into answer. So in this case, that's where my answer is now going to be yes or no. So if I go with what I entered, it's no. And then in here, what I do is on that last line of code is I update it, which means that I'm saying, remember, in C, I'll go to this side first and I'll calculate it. So hours right now is still 0. So I'll go 0 plus 1 is 1, and then I'll assign it over to the left side. So that means hours is now 1. I'll go back over here and I'll check again. Okay, so my hours is now 1. Is 1 less than 3? Still true, so I'll go back into the loop. I'll go through the paces again, and in here now I'll do 1 plus 1 to get my new variable. So that's going to be 2. That's going to be assigned into hours, so hours is now 2. And then I'll go back and test the condition again. So this time I'll go is 2 less than 3. Yes, it's still true, so I'll go into the loop. I'll do this whole business again, and this time my hours is now equal to 2, so I'll do 2 plus 1. So hours will now be 3. And then when I go to test the next time, is 3 less than 3? It's now false, which means that I do not go into the loop. I break out of the loop. So when I exit the loop, that means that my hours is now equal to 3. So sometimes when you write different pieces of code, it's really useful to kind of do, you go in the loop to kind of get to a particular number. So you want to know what it is after you come out of the loop. And one of the most common errors that you make is coming out of the loop with something that you didn't realize what's going to be outside the loop. So you miss the actual thing. So, and then I just return and all my variables die, are slow and not slow. They're just gone. It's not slow. All right, so that kind of gets that type of while loop where we count. Now, there's other types of loops as well. There's, you can have different types of conditions. Yep.
What if she had gotten the ticket in the first hour?
Well, nothing would have happened because my condition was that it has to go to 3. Yeah. So she might have gotten 3 tickets and then sold them for more money, which I hear was all the rage, also called scalping and potentially illegal. Is it illegal in Australia? It's illegal in America. Is it illegal in Australia? It is illegal in Australia, so I don't recommend doing that. Don't do that, Sophia, even if you get 2 tickets. Yeah. Okay, so we could change the condition to something else, right? We could stop the while loop when she gets a ticket, right? And that will potentially be a different condition. So if we check whether or not she's gotten a ticket, we would need to restructure this loop. Why not? Let's do it. And when you first start out coding, for some reason, the loops that make the most sense are the counting loops, right? Because it seems really reasonable. You count something, you stop when the count stops. And the loops that everyone hates are Sentinel loops. They really don't make as much sense. So we'll look at those in a second. So let's do this condition loop, which is basically when we'll stop when it's a yes. Okay, so I kind of want to do in here, but this is the wrong place to do it because I started doing this code and now I'll have to go into the count loop. I'll move them around after the lecture. But let me do in here instead so that it doesn't... No, you know what? Let's just do it now and then it's done. Okay. All right, so now let's change this up to be stopping when it's a yes. Okay, So if I'm going to stop when it's a yes, I'm just going to keep the outlines just so that I don't have to do it again. What will be my loop control variable? What am I kind of controlling? What am I using to control the loop? Which variable? Yeah. Yeah, the answer variable. So that means that I can't have it inside this while loop. And the reason for that is when I exit the while loop, when it gets to this little curly bracket, that variable dies, okay? Because I've declared it inside that little block, and that means when it gets to the end, it's no longer there. I don't have access to it over here. If I tried to find out what is inside answer, I wouldn't be able to find out. So if I wanted to, and this is just to show you what I mean. So if I wanted to do that and print out what the answer is, whatever was scanned in, and this is going to, I'm going to make that 2 to make it go faster. Okay, so now if I compile it, okay, and then what it's saying here is error, use of undeclared identifier answer, okay? Even though I've declared it over here on line 18, it no longer exists. It's only available in this little block of code, and then it's gone. So if I want it to be available as my control variable or something that I use to control my loop, I'm going to have to put it outside the loop so that it's available everywhere. You can ignore this bad style, the tabs, and there we go. So now I've got the first thing over here. I'm going to print out, did you get a ticket to Taylor? I'm going to scan it in. I don't need the hours. What will I use inside my while loop? So what's going to be the condition inside my brackets that I check for? Yeah. Okay, yeah. So I'm going to say if C is not equal to yes, it is answer, yeah. I was like, oh, I named a variable something bad. Wouldn't be the first time. Okay, so if answer is not equal to yes, then we're going to keep doing this loop. All right. Now, do we think this is going to work in its current format? Hey? Surely. There's so many opinions on the forum. Yeah? Sorry, So, yeah, so this is not initialized right now. So when it gets to over here, okay, answer has nothing in it. There is nothing in it at all. It's not initialized, it's just declared. When I get it to over here and it's like, oh, well, now I need you to use answer, there is nothing actually in answer, so it's not, the whole program is just going to go, not today, no thank you. And if we're to look over here, I really don't like it side by side. Whoever said side by side was better. And your error is use of undeclared, no, wait. Where am I? You've used the, you know what's wrong? Okay, there we go. I was like, that's the wrong error. Warning, variable answer is used uninitialized whenever function main is called. And that's because I haven't given it the initial value, okay? And that can be quite dangerous. So we want to be giving it an initial value. So I could give it the first value. And since I'm checking here that the answer is not yes, I'm going to give it an initial value of no. So I've started out on the premise that I haven't got a ticket and I would like to get one. Or Sophia would like to get one. I really don't care. Okay, what do we think now? Do we think now it's going to do good things for us? Why don't we try it? Since no one wants to. All right, let's compile it. I'll just clear it because it is actually awful on this screen. Okay, did you get a ticket to Taylor? No. 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 no, 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 no. Let's break out of it. Yes, and it's broken us out of it. And then this little y over here is from line 21, where I've asked it to print out what the answer is. So it works to break us out off the loop at the right time, fitting that condition. How could I break that loop, really? Or not break it? What can I do to test out that it's working? What would you do? Yeah. Yeah, you would try a different character. That's a good one. So, I don't know, I mean, it really doesn't care because all I'm checking for is that answer does not equal to y. So you could be putting any character in at this point in time, as long as it's an ASCII character, and it would just keep going until it's a yes where it will break me out of it. So as soon as I do yes, it will break out and then it will go down to the bottom and it will actually break us out. So that's using some sort of other condition to be able to test your loop, not just counting up or counting down. That's being able to do loops like that. And now I think we should look at a Sentinel loop. Has anyone ever heard what Sentinel means? Yeah. Yeah, so it's kind of like a flag, right? That's an easy way to think about it. Sophia? That was it. So, because when we use a loop, usually we that was. There we go. Good catch. Good throw. So basically, a sentinel is kind of like a flag, and it tells the loop when we can stop. For example, you might want to keep scanning in numbers until an odd number is encountered, and that's when you would stop the scanning process. And you know that you can stop when you kind of have seen that happen, or you scan until a negative number comes in and you keep going until that happens. So it's something that happens and you set a flag to it and then you turn the flag on and off depending what's going on. Okay, should we do a sentinel loop? I've got an example here, but I don't really want to use that example now that we've gone on this. I can't really think of a Taylor Swift example. I really like the odd one. Maybe I'll just have to... Hey? Well, I've just done yes or no. I just want to have a flag. All right, I'm going to do a different one. I'm just going to do a flag. No Tay-Tay. Sorry, Sophia. That one's a hard one. Okay. Why don't we do the one that's... Oh, I actually have a problem in here. How amazing. So prepared. I want to read in some numbers until a negative number has been entered and sum up all the positive numbers. Whew. A story of many parts over here. Okay, let's talk about how we can solve it. And because I seem to be really struggling for space real estate. All right, so what do you think I will do in this kind of problem? So I want to read in some numbers and I want to keep reading them. What are we going to do? Who's going to give me these numbers? No one's going to give me the numbers. Wednesdays are really hard. Are you just going to give me numbers? I was like... Oh, I didn't realize that. That's my favorite number. That's awkward. Okay, so let's see when we get to it. So really, some steps to solve the problem is keep scanning in numbers. I would want to check if a negative number, or not even keep scanning in numbers, but scan the first number. So I would scan in a number. I would check if that number is negative. And if negative, I would stop scanning. Else I would keep scanning. And add it to the total. Okay, so all positive numbers are going to be summed, and then as soon as we get a negative number, we exit out of the loop. Okay, seems reasonable. So what do we need? What do we need to kind of start this problem?
First, initialize a variable, then we use the scanf statement to actually scan whatever number the user gives.
Okay, sounds good.
We use the while statement for the loop.
Sounds good. All right, let's try that. Okay, so let's call it int number, another exciting variable name, and I'm going to use that to scan into. Now I want to be able to keep scanning, so I'll scan in my first number, so scanf, and I'm going to scan into it to initialize it. So it's a %d, and I'm going to pop it into this number. So now I've got a number inside there. What should I do now? We don't have a loop yet, I realize that. We will add it once we keep going. So I really want to check if that number is positive or negative. Yep.
The while loop for while number is less than 0 or greater. It depends on how we actually think.
Yeah, there's many ways to do it, exactly. So sometimes it's easier to think of what happens inside the loop, then add the loop later. Sometimes you'll do the loop itself. But I also want to sum the numbers, so I'm going to need another variable. And I'm going to call it int sum, and I'm going to initialize it to 0, because the first, to start with, my sum is 0. Nothing has happened yet. Okay, so I want to be scanning in some numbers, and if now what I do, if in here, if I were doing the while loop first, if I say whilst number is greater than 0, what's going to happen? Is it going to work? Yeah. Yeah. I do need to add it to sum, but will it be able to do this? No. Why not? Yeah, number's got nothing in it right now, okay? It's not initialized, which means that nothing is going to happen, okay? So I'm not really going to be able to do it. So there's different ways in which I can solve it. I can force it to go into the loop by just giving it any old positive number, and then it will force it to go into that first loop, and then I can just scan it in and change it straight away. And after I've scanned it in, I can check whether it's positive or negative. So if that number is greater than 0, then what do I want to do? I want to add it to the sum. So, okay. So the reason also that I've initialized sum over here to give it 0 is because when I add to the sum, or when I total up my numbers, I'm going to ask for the variable sum as well. Okay, and if there's nothing in there, if it's not initialized, it's not going to run yet again because it needs to be initialized. So it's going to go 0 plus whatever the number is, and then beautiful. Okay, now if that number is, what happens now? Do I need all these lines of code? Does it make sense? We can try running it. Sometimes it's easier to see what it does when we've run it. We can see what it does. Yeah? Okay, glad to hear that. All right, so let's run it. It's waiting for me to do something. So if I do 5, okay, there's also no way to check it because I don't print out the sum. If I do -3, it will at least break me out of the loop. Okay, let's print out the sum over here so that we know what's going on. Okay, so let's compile it again. Let's run it. And let's try some numbers. So 5, 4, 6, and let's do a negative number. Okay, so the sum is 15. It stopped when I hit -4, so that kind of worked. Now what's a bit extra in this piece of code? What do you reckon? Yeah. Well, the -4 is just what I'm inputting into the terminal. But what do you think? So here I'm checking my loop condition is that whilst a number is greater than 0, I'll keep moving. Yeah? Pardon? That's right. Do I really need this? Because I'm only inside this loop because my number is greater than 0. So do I really need to then also check that the number I scanned in this case, the way this code is written, not very nice. What happens if I remove it? Will it still work? Should we try it? Let's have a look. All right, so let's do 4, 5, 6. Oh, that hurts. Okay, so now it's telling me that my sum is 11. And why did it do that? Yeah. Yeah, exactly. So the reason it did that is, even though this feels a bit extra, but it's because it hasn't exited the while loop. So it just went step by step, completing the next line of code. Okay, so the sum still worked. So I could rejig this whole code to not be like this. I could rewrite it in any number of ways. Yeah. Yeah, so exactly. So I could move it up, I could move it down. There's a myriad of ways to do it. I could also do it, I could check for different things. I could do it outside. So in coding, there's always a whole bunch of ways to solve problems. It's never just one right or wrong. And that's how we can clearly see when someone is plagiarizing someone else, because they're solving something in exactly the same way. Please don't ever plagiarize. Thank you. Okay, so that's just some very simple while loops. Don't worry, you'll be using them so much. They're going to become second nature in about 2 weeks. And then when you kind of give up sleep in about week 6, you'll be all about the while loops because you'll be doing arrays as well, and that's going to be exciting. So I think now is a good time to do 5 minutes break, and then we're going to do a loop inside a loop just for extra fun. So let's do 5 minutes. It's clearly subtracted this -1, yeah. So that means that you are as a format, you've got sum is 0. You scanned in the first number in here, and then you checked it. Yeah, you can do that because then that's just taking in the first one. So that means now it goes in here. You did 1 is greater than 0, so you went in here. Oh, and then you rescanned it, so you missed the first one. That's what happened. Okay, so if you do it, always. Sorry, let me. it's easy if you do it at the beginning as well, if you do this. So what you do is you go into your main, yeah? And then you declared number, so you've got number here, it's got nothing in it right now. Next line you've got sum, and you've given it a value of 0. Then you scan something into number. So you've got the numbers 1, 2, 3 that you're using. So the first one, 1. So 1's gone in there. And then you've checked the loop. So now you're checking, is 1 greater than 0? This is true. So I'm going to go in the loop. And now you're scanning in the next number without having done anything with that one. So now you scan in the 2, which means this is now 2. And that's why you skip the first one, basically. So one way to do it, like in this really simple example, is if you just say, okay, the first one is just equal to any positive number, I don't care, and then you don't scan in anything here. It's either that, or you move that scanf, so because you've scanned in the first one, then you want to check if it's greater, you add it, and then you move the scanf towards the bottom of that while loop, because it executes in order.
Wow, okay, thank you.
Yeah, no worries.
Hello, teacher. So I just want to ask you, for these problems, I think I can use the unsigned char to solve this problem.
We don't really want you to use an unsigned char. We just...
Can I use the unsigned?
So there's no negative shifts. You don't have to worry about negative shifts.
Negative shift. Oh.
You don't have to worry about negative shifts.
Oh, okay.
Yeah, yeah.
So
I think we wrote it down because we forgot to write it before, but then it was fixed.
Yes.
And we wrote that you can't...
because we will meet the number will out of the 127 and it will come to the negative 128. So if I think I can use the unsigned char to solve this problem, and in the end I can use the char again.
Yeah, so we want you to not do that. We want you to stop, like, because we're only playing with a small portion of the chars, right?
Oh, yeah.
And I swear we wrote it in here. So if you check where it is, you can wrap around. So you can only do it in shifts of 26, right?
Yes.
No more than that, which means that you can use the modulus operator to kind of see how far it's gone and what's the leftover, and
Yeah.
then you know how many to wrap around,
Oh.
as opposed to going, 200 and then deciding what's going on there.
Okay.
Yeah, so think about using the modulus, which gives you the remainder.
Okay,
Yeah.
thanks.
Yeah. That's all right.
You don't want to use instruments and arrays. You want to consider kind of negative it. Also contributed into this.
Yeah, and that's because over here, where the scanf is, it's scanning in the -1 in, and then it's just adding it to the sum. That's why. So now, so you can change it by shifting around where the sum happens and where the scanf happens, so you can fix it.
So say you enter n is greater than 2,
Yeah.
it should be off.
Well,
Technically entering the character n.
it doesn't. So
that
what
new line
happens?
character
Okay,
is
here.
sitting in terminal,
This is how it works.
and when
So
it
you've
hits
got
the second round,
starting from the very beginning. You've got your first number.
I've got a new line character sitting there. The user's been
And then you've given it the value of 1.
again for another
Then
one.
you
I'm just going
declared
to use
sum
sum and not
and then a value of 0. Then you
So
go
make
to
sure you have the space
121 and you're going to check if number's 1.
No
Is
worries.
1 greater than 0? That's true, which means you go into the loop. Yeah? So you're scanning the first number. You've got 4 and 5 as your numbers and -1. So you've scanned in 4 and placed it into numbers. So number is now 4. Okay. Now you've gone into sum and you said sum is equal to sum plus number. So 0 plus 4. So that's now equal to 4. And then you've gone back out and back to the while loop, and now you're checking is 4 greater than 0? True again. So you're going to go into this loop, and you're going to scan the next number in. So you're scanning in 5, which means number's now 5. And you're going to add it to the sum, because the next line just says add it in. So sum is going to be 4 plus 5, so now that's 9. You're going to come out again and check the number being greater than 0. Your number's now 5, which means you're now checking is 5 greater than 0. True again, okay? You go into the loop, and you scan in the next number, and the next number's -1. So now it's -1 over here, and then you add it to the sum. So now you're doing -8, and then you go back and you check, okay? So then the check happens too late. Yeah, so you can rearrange the loop, or you can just keep the if in there, which will keep before you go back to. So if you change the positions of some scanner, yeah, and run it now. It's going to give you actually the wrong answer because the one is going to come. So now it's counting that first one, which is why it's giving you the answer. So you could scan the first number out here instead of initializing it to that. So you can have the first scanf happen outside of the loop. So what you can do is you can just have this, and instead of initializing it here, because you're in 10. Just go edit it. I haven't copied it because I pressed Control C. So just have that up here as well, and then that means the first number is going to count. Now you go edit, copy. Yeah, so now it will work. And so whenever you're in start, literally get a piece of paper out and then you're on the computer and run through it line by line. It will really show you the errors straight away. Which one? Yeah. You can remember it. So it really depends how you structure the logic of it. Right? There's many some ways more efficient. So when you're just starting out coding, you will not do anything to prepare for that. You don't need to, right? It's many it's like math, right? You can do math and math, and you want to get it right every time. It's similar to the no worries. All right. Let's put a loop inside a loop. How exciting.
If you saw the results of it for loop so far.
Oh, not bad. People are really kind of getting loops, I hope, a little bit. Okay. So it looks like people are understanding loops. So let me make it a bit harder by doing a loop inside a loop. So I feel like the best example of a loop inside a loop is a clock, because the second hand is moving, 60 times for each one move of the minute hand, and then the minute hand is moving 60 times for each one movement of the hour hand, blah, 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 blah. So that's kind of like having a loop inside a loop. So that means that each time, the inside loop runs all the way, the outside loop, runs one. So the inside loop is the one that ends up running many, many, many times. And it's a way for us to kind of control things as well. So doing something like this, a grid of numbers, would require a loop inside a loop, because we're going both this way and we're going downwards and we're repeating it, and we're doing it a whole bunch of times. So let's try and do this problem and break it down as well to something that we can solve. Okay, so let's have a look at what we can do here. Okay, so I guess in this particular question, I've kind of hard-coded the value of this square. It's going to go, 5 across, 5 down. It's a square. Not bothering. You can, of course, we can vary the input or the size of the square by taking in an input from the user and then modifying it for that. We can do it afterwards. But let's try it with a hard code first. So let's say it's just going to be a 5 by 5. So I've defined the constant here, and the constant is equal to 5 because that's the size of my square. And now I want to be able to kind of control it. So something else that you'll find about me is I have a real problem with rows and columns. So just bear with me. Columns are the vertical things. Rows are the ones across. And I have to repeat that in my head every time I say row or column. So I'm going to do it in rows and columns, and then I'm just going to break that next week and go I's and J's. So, and it's really one of the only times you don't have to use row and column and a very specific name of the variable. You can use I's and J's because it's a very standard thing to do. Okay, so I'm going to have a row, and I'll initialize it as well, and I'm going to have a column, and I'm going to initialize it as well. Okay, so I've got two variables. I've got a row and a column now, and I want to be able to do something inside my while loop that will keep me going for a little bit. Okay, typing with one hand is not a strong point. Okay, so what do you think I'll test on the outside, the row or the column?
We can start using from rows, like rows less than max, because we have already defined it.
Yeah.
And then after it goes to every value of it, we can also declare initialize column. We have also already declared it, so we just initialize it. The same loop will use it.
Yeah, okay, so very good. Okay, so there's going to be a few things we're going to do. The first time I'm going to write this code, I'm going to make a mistake in it so that you can see the most common mistake that is ever made. And this will apply for arrays as well. And then I'm going to show you why that mistake is made, and then we'll fix it. Okay, so I'm going to start by first checking whether column is less than max. So I'm checking whether the number of the column is less than this max over here that I've defined as a constant. And if it is less than that, then I want to be going inside my second loop, right? Because I want to be doing something, so I'm going to check that row is less than max. Okay, fantastic. Okay, and whilst row is less than max, I want to print out the number. And I'm going to print out the row number. Okay, we're going to see why I'm doing that in a second. And then I need to increase my variable. Okay, so I need to move across by 1. So I'm standing at 0. I'm going to move to the next one. So I'm going to do row is equal to row plus 1. And that will move me along by 1. Okay, great. So we'll see what that will do in a second. Maybe I'll run it now to show you what it does. We're going to encounter a bit of a disaster if I run it now, because I'm going to enter an infinite loop because I'm not doing anything with the column variable, okay? It's just staying constant. So what I'm going to do is I'm going to increase it as well by 1, which is what I normally do in a while loop. Inside the while loop, the last thing I do is update that loop control variable. So let's have a look what that does before we move on. And then we'll run through it to make sure, because right now I'm sure it doesn't make as much sense as it could. What's it called? Grid.c. Okay, so what it's going to do is it's going to print out the numbers 0, 1, 2, 3, 4, and then it's going to call it a day. Okay, so it's done something, but it's not done what I wanted to do. So few mistakes. I guess when we start kind of doing this type of coding, we can see the easy, the low-hanging fruit. What can I fix first? It starts with 0. I don't really want it to start with 0. I want it to start from 1. How will I start it from 1? It's the easiest thing to fix. Yeah. Yeah. So instead of initializing at 0, I'm going to start initializing at 1. Okay. So notice here that I've printed out 1, 2, 3, 4, 5 things. Amazing. Do you think I'll print out 5 things now? It's a trick question. I won't. Yeah. Thank you. I will not print out 5 things. If I run it again, obviously after saving it, I keep doing this big anticlimax because I keep forgetting to save. If I run it again, what's going to happen is I'm now going to go 1, 2, 3, 4. Who knows why that is? Yeah. Yeah. It's because when I get to column is 5, is it less than 5? Well, it's not less than 5, but I still want it printed out. So I really need to have these as less than or equal to, because it will keep the 5 going as well. Yeah.
Gone like less than max plus 1, right?
You could do that as well. Absolutely. Okay, so now if I run it again, I'll have this beautiful line 1, 2, 3, 4, 5. It feels like I'm a little bit closer to somewhere because I've now got the first line of this grid. But I've only got one line, right? There's not 5. I've only got just that one line. I could have done that without doing 2 loops, really. So let's see what's going wrong. Okay, so this is where it's really useful to have, yeah.
I think the column isn't being reset.
Very good. Okay, and let me show you why, okay? So for those of you that heard that, the column is not being reset, and that's exactly right. But what that means is, this is going to be able to draw. Okay, so this is what happens. My row is equal to 1, my column is equal to 1, fantastic. So the first time I go into this loop, it's going to check that 1 is less than or equal to 5. This is going to be not that pretty. That's true, so I'm going to go inside here and I'm going to check that row is less than max. Great, that's also going to be true because my row is still 1 as well over here. And I'm going to print out whatever the row number is, which is currently 1. So that means that's where I'm going to print out that 1. And then I'm going to change my row to row plus 1. So that means the row is now going to become 2. And I'm going to go back into this internal while loop, okay? And what I'm going to check now is that, okay, it's no longer 1. So I'm going to check that 2 is less than 5. Yes, it's still less than 5. Great. So I'm going to go inside here, or equal to. But equal to is not as nice to write. I'm going to print out whatever the value is. In this case, it's 2. And then I'm going to add 1 more to it. So now that's going to be 3. I'm going to go back here and I'm going to check that 3 is less than or equal to 5. It is. So I'm going to enter this loop. I'm going to print it out. So now I'm going to get a 3 there. And then I'm going to increase it by 1. So that now becomes a 4. Great. Go back and I'm going to check again. So now my check is going to be whether 4 is less than or equal to 5. So I'm now in here. It's still true. So I'm going to print out the 4. And then I'm going to add 1 more to it. So it's going to increase to 5. So then on the next line, what I'm going to be doing is I'm going to check my loop again. And I'm going to check that 5 is less than or equals to 5, which it is. So I'm going to go back in here and I'm going to print out the 5. Then I'm going to add one more to it because the next line of code asks me to. I'll go back over here and I'll check. Is 6 less than or equal to 6? It's not. So that means I'm going to break out of this loop. And I'm going to do the next thing here. Okay, so I'm going to increase my column by 1, so that's now 2. And then I'm going to check my next thing. Is 2 less than or equal to max? Okay, so that's going to check, is 2 less than or equal to 5? It is. Fantastic. That's working nicely. I'm going to go inside here, and it's going to check whilst row is less than or equal to max. My row is still 6. Okay, it hasn't changed. So that's not going to be true, which means I'll just go back to here. I'll skip that while loop. I'll go back to here. I'll increase my column again. I'll check that again. I'll go in here again. My row is still 6, so I'm not doing anything again in here. It means that I'm never entering my internal loop again, okay? Because my internal loop is always going to be out of that condition. So what I need to be doing is I need to be resetting that internal loop every time, okay? Just like your clock, right? It gets to 0 again and then it starts again 1, 2, 3, 4, 5, 6 to 60, right? It doesn't just stay at 60 the whole time. Okay, oh, I'm still on that. So in here, I'm going to reset my row back to 1 and then I'm going to start again, right? So let's see what happens now. Okay, so let's compile it and we'll run it. And okay, getting one step closer. It's printing out 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and it's doing it 1, 2, 3, 4, 5. It's doing it the right number of times, but something is still missing, the new lines, yeah? How do I, hey? Yeah, where do I put it?
Just after we exit the internal while loop.
Okay, great, sounds good. So I'll put it in here. So that means I finished one whole row. When I get outside of this loop, this means that I have finished one row. And that means now I want to be able to go a new line and then I'll start my loop again somewhere in there. So let's try it again. And let's run it. Ah, voila. We've got a loop finally. How do loops inside loops feel? Oh, amazing. Yeah. Ah, yes, I've got a constant over here that I've defined as 5. Yeah. And I can, I can scan in a value from a user and we can do any, if I don't want to have this hash defined, what I could do is I could have in size over here and I can scan in a value into that size. Okay, and then I could compare it to the size instead. Okay, so that could get crazy. So if I run it like that, and then I don't know, 9. That doesn't help that I haven't compared it here to the size. Okay, let's try that again. Again, an anticlimax. So if we run it again, and I'll do 9, now I'll get, a 9 by 9 square. So I don't have to hard code. It was just for the example. Okay. Did you run a poll by chance to see? Oh, it is happening. Okay, excellent. Okay. Okay, looking good. Oh my gosh, we're going to get to structures and enums. Yay. No one's going to be yaying after that. Structs? Not too bad. Yeah, they make sense. Maybe. All right. Sorry. Yeah, so the internal one runs many, many times for like one loop of the external kind of thing. I always like, I don't know, for me it's the clock, you know, the inside runs many times. Yeah. Say it again. So like change up the row and the column. Yep. So, I mean, you could, but it's not going to give you the perfect grid, because what I'm resetting is I'm resetting this bit over here. I'm bringing it, so like if you think of it like a typewriter, I've gotten to the end and then I move it across back to this to go again. And then I move it back to over here to go again, because that's the row that goes on the inside. But play around with it. The best way to kind of try things out is to play around with things a lot. My gosh, people are really going great. Not that many people are voting, so I'm just going to take that as a vote of confidence. Enough? Okay. All right. And don't worry, next week we'll kind of rehash all of this again. And you will cover it in your tutes as well. So you will get a lot more while loops. And really, while loops are here to stay. It's all you use. Well, maybe we'll do for loops, and then that's all you'll be using in your arrays. Similar thing. Okay, fantastic. So let's talk. Can you do another one to do like too fast, too slow? I guess no one wants to raise their hand. Too fast, too slow. Am I going too fast? One, no? Someone just said no. Am I going too slow? You're probably an anomaly. Yeah, I can't see that far. If people do thumbs up, thumbs down. You're doing the poll? Yeah, okay. If you tell me in the poll, okay, Just Right is winning. Amazing. Like the cereal. Perfect. Although that cereal would never win anything. All right. Okay, good. Then we're up to structures. And then we'll go over things again. All right, so structures, or structs as they're known in C. It's short for structures. And it's a way to create custom variables, basically. What it means is right now what we have had is we've had one type of variable. You know, if I say an int, it has to be an integer. If I say a char, it has to be a character. And it's only one thing, okay? But in real life, sometimes you have a variable that you want to be made up of many variables or a few different types of variables. One like sort of example of that is like, let's say I've got, you know, my coordinate system, I have an x and y coordinate. I really want them to kind of mash together because they make up one point, and that's a, you know, a really lovely place to use a struct in. So that's one way to do it. So structs help us to organize related things into one component, and you can have different components. In the example I gave, the coordinate, it's got both ints, but they don't have to be ints. You can have chars in a struct, you can have doubles, you can have strings, not that we've learned about strings yet. So you can have all sorts of things that might belong together that you're just kind of organizing and categorizing nicely. Okay, to create a struct, okay, there's 3 steps. First of all, you define that struct and you define it outside the main function. Then inside the main, you declare that you're going to use that struct. And you initialize it as well inside the main, and you assign some values to it. So I think, shall we do it inside code? Let's do it inside code. Okay. Oh, this is the one where I was like the Tay-Tay friendship bracelets. Okay. Because, you know, I don't know if anyone knows, but they've run out of supplies in every craft shop in Sydney. If you wanted to buy beads, you would not be able to, apparently, these days. So just in case you wanted to make friendship bracelets later on today. Let's just do it. Why not? Why not? Okay. So let's say I want to have a friendship bracelet, and in that friendship bracelet, I'm going to keep track of a few things. Let's say 4 things in this one, just so that I can show you that I can have different things. Sorry, I'm also leaning very unnaturally to get the microphone. So I'm going to say how many beads there are, how many letter beads there are, and then the length of the string of bracelet in centimeters, and then the initial of who this bracelet is for. Even though I think you exchange it with randoms, I don't know. Okay, so let's have a look. Okay, so to define the struct, you do it outside of your main, okay? And to define it, what I do is I use the keyword struct, and then I give it the category that I'm doing. So, I don't know, friendship, how beautiful. Then I open up a curly bracket, and note that when I do a struct, after the curly bracket, I also put a semicolon, which you have not done until now. There is a reason for it. That's because you can have other definitions happening. You can define this type, but we're not going into that yet. So just trust me on the syntax for now. After you define it, you will put a semicolon after it. Okay, so now I've got an int, so int number of beads. Great, and then I've got another int for letter beads. And then I've got the size in centimeters, so this is a nice one to use a double. I'm going to call it size. And then I'm going to have a char for the initial of the person that this bracelet is for. Okay, so I've got 4 things inside my struct, and that means my variable is made up of 4 things. It's made up of these 4 variables rolled into one. And it means that I don't have to define 4 variables for each kind of case of one related situation that I want to demonstrate. Okay, so that's my first step. Then the next step is that I will declare that I'm going to use that struct. So to declare that I'm going to use it, the definition of it is struct friendship. So I'm going to use the keyword struct. I'm going to say that it's friendship, and that's because I can have many different structs. So friendship allows me to reference which struct I'm referring to, because I could have more down here. And then I'm going to give it a variable name. So I'm going to call it bracelet. I don't know, awful name. This is awful, actually. Anyway, awful names. So what's happened now is I know that I'm going to use a struct. I've declared it. I haven't initialized it. There's no values to it. So now to assign values to a struct, we're going to learn some new syntax again. What I do is I use the variable name. So normally, you know, if I've got like an int, so for an int, I will say, okay, int number is equal to 10, and that will be enough for me to kind of declare and initialize something. Here I've declared it. I can't initialize it on the same line because bracelet is actually made up of 4 different components. So I have to be able to load up the different components of this struct, okay? So to assign to the different components, I'll use the same way as an int. I'll use the name of the variable, which is bracelet in my case. And then I'll use a little dot. And then I'll say what I want to assign to. So if I want to assign to the num heads, num beads actually, so num beads, let's say this one has 10 beads. Okay, so that will assign that value. Then the next one, let's say there is 5 letter beads. So I'll give that a value of 5. And then I'll give it a, I think it was called size. And I'm going to say it's 12.3. And finally, there is a character, I forgot what it's called, initial. So I'll put it into initial, and I'll give it an initial, and it's going to be for Sophia. Okay, so that's going to load up all of that, and it's going to assign the values into that struct. So then if we're to see it in action, I'm just going to do one just to start with, but you can do any. So let's do bracelet. Just so that you can see exactly in the same way, just using the slightly different syntax before, because I have 4 different things in that struct. So if I compile it now, structs. Okay, and then I run it. I'll have this beautiful, the friendship bracelet has 10 beads. So that's a very basic struct, okay? You will learn how to use them in obviously more complicated ways. It's never going to be this easy again, sorry. This is just lulling you into a false sense of security. But think of it, it's just another type of variable that is available to us and that we can use when we want to combine things together and to have different types of things in one variable. Okay, so that is a struct, okay? Now let's have a look at another data type because one wasn't enough. And this one is an enum. Okay, who's heard of enums before? Few of you. Okay, enums, at this point in the course, it's going to be hard to demonstrate for me why they're useful, okay? Because you're not really doing so much that you can't do it, you know, without just defining some constants. But basically, enums are enumerated constants, okay? So what that means is enums make your code easier to read for someone else. Often it's just much easier to access the code as well in that way, and easier to maintain it afterwards, okay? So basically what enums do is they, similar to structs, you declare them, you define them outside of the main, and then you declare them inside the main, and you use them inside the main as well. So the way that we do it is in a very similar way. I'll do a very simple one, and then I'll do this complicated example that I came up with. That is just, I can't decide if it's awful or not. Enums, there we go. So enums are often used to keep track of like error codes that you get because there might be 500 of them, so it kind of gives you a definition of each error code. And you will use enums as well in different ways and in the assignment, and it will become more clear kind of why and when you need them. So let's just have a look at a very simple enum just to give you a little bit of a how to kind of use it, declare it, and what to do with it. So I will define it again outside in a similar way to a struct, and that's why we do them together. So I'll use the keyword enum. Let's say I'm going to do weekdays. I will give this enum a name that I will refer to it. Again, remember, I could have many different enums that I use throughout, so that's why the enum itself has a name, and then I'll have a variable of type enum, whatever it is. And then we'll do our curly brackets as well, and let's say I'm going to do like this. Okay. So what that enum does is it enumerates the constants, okay? So it will assign numbers to all of these, okay? It'll go 0, 1, 2, 3, 4, 5, 6. And you should never rely on like the numbers being right. You should refer to it by whatever the value is that you've called it. So similarly to a struct, I have a semicolon at the end as well. So now that I've defined an enum, I've said, okay, there's an enum weekdays. It's got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday in there. I'm going to declare that I'm going to use it inside my code. So I'm going to use an enum of type weekdays, and the variable name is going to be week. Okay, so then I might assign, actually week is not a, let's call it a weekday. Okay, so then I can set something to whichever day I want in here. So let's say we'll set it to Wednesday because today is Wednesday. And that means that it's now sitting on this one. So if I print out what the value is of it, without caps lock on, and it's going to be a %d because it's enumerated, and then I will refer to it by whatever is the variable name. What do you think it's going to print out? Thank you, whoever said that. It will print out 2 because we've got 0, 1, 2. Okay? Okay, so if we... All right, so if I run it, the day of the week is 2. I can also do other things with enums. Perhaps I want to force it into some sort of number. I could actually say, you know what? Wednesday's 400. Okay, so then what it will do is, if we run it, and we run it again, it'll say that, okay, it's 400. What do you reckon it's going to do if I then say, okay, I want this to be Thursday? What's Thursday going to be? Pardon?
401.
Yeah. So it will just continue counting from wherever it kind of... So this is going to be 0, this is going to be 1, this is going to be 400, 401, 402, 403, 404. It's one of the reasons you should never rely on, on the value, the integer value of it. You should just call it by whatever the name is. Okay, so I've got this quite complicated example of using it, which is all about Taylor Swift. I'm sorry. Not feeling the vibe now of the Taylor Swift situation. Oh well, you're all stuck here now. I've done my research, so now you're stuck here. Okay, so apparently Taylor Swift made an album for each era of her life. And she started at 16, didn't she? Do I know more now? Oh. Okay, now I needed a piece of paper to remind me what on earth all of these things were called, but what I've also done, so as not to bore you all to tears, is I've actually just put them here so I can copy and paste them in. Because there's a lot of them. She has been a very, very busy lady. Okay, so I've got all the names of the albums. Amazing. And what now I'm going to do is, I had no idea what was going on, and I want to know, how did she have this much time in her life to make so many albums? So what I would like to do is I would like to find out which year she made each of the... I'm going to keep the simple example in here so you can go back to it. So what I'm going to do is I'm going to literally ask the user for some input, and then based on whatever they input, whichever era they want to know out of her albums, I'm going to tell them what year she produced that album. How amazing. I don't feel the excitement here for this. Oh my God, if only you knew what music I listen to. Okay. Okay, and let's say, how many albums are there? Is there 10? 10. 11. Who said 11? Oh, amazing. Okay, great. I'm going to ask for some sort of input, and because I used an enumerated data type, all of these now have numbers to them, okay? So some sort of number is going to come in. And I'm going to scan in some input from the user. And then what I'm going to do, because there's going to be so many possibilities, I'm going to, again, not bore you to tears, and I'm just going to take them from here where I've really went to town with them. Okay, I'm going to do this first. I know, awful. Okay, so this is called very ugly coding. A lot of if, else if, else if, else if, else if. So not like particularly nice code. Forgive me. Okay, let's clear, and now let's try to see what it does for us. So I'll compile it. Enum. I'm numbing you all, so that's a Freudian slip right there. I forgot to actually declare that I'm going to use the enum, so that would have been very helpful. Okay, so I'm going to declare that I'm going to use it. So we've got enum, and I'm going to call it that. And now let's try it. All right, let's see what the issue is. Yep. There we go. Those pesky variables that are uninitialized. Okay, Sophia, choose a number. Okay, what was the third album? And it's between 2012 and 2014. Amazing, okay? So, a very weird use of enums. This is not how you would use them in real life. I don't feel the excitement from anyone about Tay-Tay. I'm sorry, Sophia. Your heart is broken.
Somewhere in the corridor when I was throwing out chocolates. Don't hide yourself. I saw it.
You'll secretly see them at the concert. They'll try and hide their cups. Yeah, just one. So this was fun for like 3 people and Sophia, obviously, an ode to Sophia. I feel like she deserves it. Okay, so that's enums. Again, it's not really clear how enums fit into the picture yet for you because they've just come out of nowhere. I could just declare many constants here, but you can see how this would get annoying if I have to hash define each of these and give them a number, right? So the enum is a way to enumerate quite a few things and kind of hold it together. Yeah. Okay. So over here, even though I deleted this was the defined enum. Okay, so that was, I defined it and I called it weekday. So that's the name of the enum that I'm using. And then weekday is the variable name of type enum weekdays. So this is the definition of it. And it's because I can have many out here. I don't have to have just one. I can have 20 enums out the start of it. And 20 structs. So that's why I refer to it by name as well as giving it a variable name. Okay, how are we feeling about enums? Not strongly, I would imagine. You don't need to feel strongly yet. Sorry, are you polling? Okay, thank you. Thank you. I feel like you can still feel positive about them. During assignment time, you can feel a bit more negative about them. I didn't do them justice either. I just haven't felt strongly about them today. It's hard to do them in week 2. There really is no point to them to start with. So the reason we use those enums over the hash defines is sort of if you don't want to define 20 or 30 or 100 different things as constants, and that kind of stops that from happening because it enumerates them automatically. you can't have an enum state that's the same in two different types of enums. So I can't have the same, Monday in 2 or 3 different enums. And they're automatically assigned the values, right? Which is why they kind of win over hash defines if I have many of them together. Because like error codes, let's say I've got 400, 500 error codes. They're all assigned values automatically. Those values might change, I don't care. But I can refer to them as whatever the name, the constant name is that I've given it. Yeah.
So, what happens if you put in like a really massive number in that's like outside of the range?
Outside, like 2 billion, like you want. That is a very good question, and I want you to try that. Oh, your keyboard's got Sonic on it. The computer, that's very cool. That is really distracting now. The Sonic is running. Yeah, what is that? I want one, yeah. Okay. All right, you know what? We're going to finish this torture today on a Wednesday afternoon. Let me know any feedback, and we will keep going next week. Good luck for the rest of the week.